Now, I'd like to switch gears a little bit and continue our discussion from earlier on arrays. Arrays, while useful, aren't the only way to store and manipulate information. In fact, there are a multitude of different ways to store data in computer science, including linked lists, stacks, queues, maps, trees, and many others too. Right now, though, I'd like to talk about two cool, wacky, and zany ways to store data that we haven't previously covered: array lists and dictionaries. But before we get into those, let's get a little review and reinforcement of arrays. As you may remember, arrays are basically lists of values that are stored together. When you initialize an array, you give it a size, and this size is fixed. You won't be able to increase the size of the array, so when you make an array, its length is final. To access the values in an array, you reference them using an index which starts at 0. What this means is that the first item of an array is not at position 1, it is at position 0, and its position is commonly referred to as its index location. So, to find the nth item in an array, you would refer to it as index location n-1. However, as the size of an array is fixed, you have to be careful to not reference a position that is beyond the total size of the array, or to append too many items to it, as this will return an error. We also have what are known as two-dimensional arrays, which is an array containing an array at each of its indexes. Or you could have an array containing arrays, containing arrays, containing arrays, containing arrays, depending on what you're trying to do. Multidimensional arrays can be useful in more advanced programs for organizing a wide volume of related values. If that's confusing at all, skip back to earlier for our full discussion on arrays. The timestamp will be in the description. Now that we've reviewed arrays, let's go over array lists. Array lists, or just lists in Python, can be thought of as a growing array. Earlier, we mentioned how you have to be careful to set an appropriate size of your array and to make sure that you only reference and append values such that you remain within the size. However, with array lists, this isn't a problem. After you initialize an array list, it instinctively has a size of 10. But if you append values such that the size of the array list goes beyond 10 elements, an array list will grow itself, meaning that the computer will allocate more memory to the array to increase its total size so that the new values can be appended. This is quite useful when you don't know the exact number of values that the array will need to store, or you want the ability to store more values to your heart's content, such as when you're making a database with an unknown amount of users that will sign up. There is a lot more to uncover when regarding array lists, but for this surface level series, that is all you pretty much need to know. So let's move on to dictionaries. Now when we're talking about dictionaries, we're not referencing that thick book you probably have lying around your house, which has thousands of definitions. In computer science, dictionaries are like arrays in that they store multiple values. However, their values are stored very differently. Rather than being referenced by their linear position within the dictionary, each value is tied to another value that is used to reference it, or its key. Because of this, we need to throw away all conceptions of dictionaries as a linear way of looking at data, since in actuality, it is much more fluid and interchanging. Basically, we say that each position in a dictionary holds a key-value pair. When referencing a value in a dictionary, you will use its unique key, and the dictionary will tell you the value that it is tied to. Think of it like this. Each time you add an item to your dictionary, your computer creates a handcrafted box to store the data, and also custom makes a jewel key, one of a kind, no other like it in the world. This way, there is only one key that goes to the box that stores a certain bit of information. Because each key must be unique, reusing the key in a dictionary will result in an error being thrown, because having two keys that are exactly the same would confuse the computer as to what box, or piece of information, that key leads to. However, you can store the same value in multiple key-value pairs, since the keys would all be different. Now, like I said, dictionaries are more fluid, making them easier to organize than arrays, as everything is set up in a more logical manner. That is to say, it is easier to find the value you are looking for when you are using keys rather than simply referencing their positions. Let me explain what I mean. Imagine you have a dictionary of prices at a store where the key is the name of the product and the value is the price of the item. Maybe apples cost $1, milk costs $2, and bread costs $3. You can see that in the dictionary, each key is the name of a product, and each value corresponds to the price of each product. So to find the price of bread, all you need to do is simply call the dictionary using the key bread. This makes it extremely easy to track values through your code, since you're working with tangible values rather than numbers which don't mean anything to you. You can also manipulate dictionaries in many of the same ways you can manipulate arrays and array lists. You can iterate through a dictionary and perform many operations and comparisons on the values. If you want to find the product with the highest price, for example, you can iterate through the dictionary to find the value that is highest amongst the grocery store items. Arrays, array lists, and dictionaries are useful in their own right, as are the mass amounts of other ways to store data, and each boast certain advantages over one another. We already covered the basics of these three, but since there are so many, we don't have time to go in depth into each and every one of them. And so in order to help you grasp the basics of storing information, we're now going to talk about one of the most important functions needed to understand arrays, which are searching algorithms.